All right, this recording is about Chapter 2 in ThinkJava in version 6.1.2, and it is about variables. All right, as it says, you're responsible for reading Chapter 2, although we will cover the highlights in this PowerPoint. There is a homework assignment at the end. The assignment is binary, that is, you get all the points, you get none of the points, and you should do it on time or not do it at all. The purpose of the assignment is for you to practice, and I'm looking for effort and not necessarily all correct work. The idea is hopefully you will do it as we go along, as opposed to waiting till the last minute and at the end of the semester handing a bunch of stuff in. So that's why it's on time or not at all. All right, other resources. There is this website, javacjava.com, and he says, there it is. And this is his presentation on variables. I will refer to this website, JavaCjava, on a regular basis. He has good, useful tutorials, and he uses only WordPad and the command line. So this is a PC-based experience, and I will give you a reference for how to do this on a Mac if you care to. We, however, in class will be using an IDE, that is an integrated development environment, and that's how I do it. I will hopefully have other YouTube vids as we go along. All right, starting with a basic question of what is a variable. And unfortunately, this is not one of the more useful definitions in many respects. A variable is a named location in memory that stores a value. And here is another set of tutorials if you decide to look at those. All right. Whenever you use anything in a computer, it's going to store it somewhere. And so the variable, it has a name for the writer and user of the program, and it has a storage location so the computer can get to that variable. All right. So a variable may be used to store a value of a number, text, images, sound, and we will come across other kinds of data as we study Java. And Chapter 2, page 15 gives you some references. Now, before you use a variable, you have to declare it, and to declare it means to let Java know what type of variable it is and what name it will have. So, for the moment, we are going to say that there are primitive data types, object data types, and as I say, that's a little bit misleading, but it'll work for now. A primitive data type is an int, a double, a boolean, and a char. And all of these should be with lowercase letters. Unfortunately, this is one of the foibles of using PowerPoint. So an int is an integer for all intents and purposes. A double is something that has a decimal point. A boolean is going to be true or false. And a char is a character, a single letter or number or symbol. And for those of you who want more information about it, this gives you the range of values and then the size, the amount of memory that each takes. Notice that there is something called a long that takes up 8 bytes of memory, being that, and a double being the largest. The only reason we care a little bit is how large are the numbers. Notice that a double has floating point precision plus or minus 10 to the 308. That's pretty big, and it has 15 digits of that are significant. An int is hundreds, thousands. It goes up to 2 billion. So you get a fair range of numbers. There are a couple of others, but you won't care at this stage of the game. We care about an int, a double, a char, and a boolean. The other are not part of the AP set. There is a subset of stuff in Java that AP cares about. Beyond that, there are fun things that we'll study, but it won't be on the AP exam. All right, beyond primitive data types, for now we're going to study about string, which is text. And if we're going to declare it, you're going to say string capital S, str. So we're telling you that it is a string type and its variable name is str. To initialize it says str equals hello world. Notice that a string is in double quotes. So I can say string str1 equals a, and that is both declaring and initializing all at once. A character, a char, is kept inside single quotes. So these are different. And if we look at this, we will see, and for some reason I've got an arrow out here. All right, I have int a equals 1, int b equals 2, double c is 3.0, and then I declare, and I will use in a moment, double d for something else, and string str is hello world. Notice that it's in bright red with double quotes, and char c1a, the way I've got my version of Dr. Java set up, single quotes are in pink for char type variables. All right, so that shows you declaring and initializing, or simply declaring in the case of D. Well, let's look and see what happens with math when we do math with ints. If I have int a is 1, int b is 2, and then I say d, which is a double, is equal to a divided by b, I get 0. Well, that's because a and b are integers, or ints, and I have no decimal places for 1/2. So this truncates or does away with everything and gives me 0. Well, that can be a pain. So what I can do is I can do something called casting. I can say d is equal to double a divided by b. This casts a, or makes a double, so that a double divided by an int is a double, and life works out well. So we'll talk about casting in class, and notice it says, but you can't cast everything you want. We'll talk about what can you cast and what can't you cast, and what are some of the problems with that. We will also be discussing a lot about integer and double math as we go along. One of the things that computers do well is they do math well, but you've got to let them know what kind of math they're working with. All right, now there are certain things that you count discretely or with ints, and that's why you need an int data type. Think about the number of coins in your pocket or in a change purse, or the number of books in a library, or the number of soccer players on a team. Hopefully you don't have half a person on a team. That'd be a little tough, especially for the person whose half it was. All right, if I'm counting coins and I've got 16 coins in my pocket, 6 are pennies, 5 are nickels, and 5 are dimes, as an example. But then you're asked what percentage of the coins are pennies. Well, you're going to set it up as 6 divided by 16, but that's going to give you 0 in int math. So at that point, you would cast one of those two numbers into a double. And that way, I think in the example I had, it was going to be double 6 divided by 16. And so a double divided by an int will give me a double in the end. And that would be required if you want to actually return a decimal value. All right. I can't remember what Mr. Martin taught you in physics. Hopefully you do. But let's talk about rounding. We've got three numbers. We have 43.4, 44.5, and 44.6. So what's going to happen, or how does one round in Java? So let's look at the next slide. And what we're going to do is we are going to add 0.5 and then cast to an int. So we're going to be rounding to two significant figures in this case. So that's what you do, and here are the results. So it turns out that both of these are going to round up, and that will round down. So effectively, 0.5 and up will round up, 0.4 and down will round down. So that actually makes perfect sense if you think about it. All right, before you start doing your homework problems, you probably want to go to GitHub at this address, and you will find that they have all of the code for all of the that's used in the book. So that should give you a hand. Also, on occasion, a homework problem will refer back to a problem that was done in the book, and this will give you some help. So on pages 30 and 31, I'd like you to do all the parts of exercise 2.2 and 2.3. I would like you to write a brief explanation of the difference between a compile time error and a runtime error. These are errors that will rear their ugly head on a regular basis, and you will need to know which is which and why they occur. And then also I want you to explain the difference between these two pieces of code, print or system.out.println and system.out.print. What will be the difference in the outcome? Okay, there you go, chapter 2.